So this lesson is piecewise functions. So our learning target is I can evaluate and graph piecewise functions, and I have no idea why there is a comma between piecewise and functions in the learning target. That's okay, just pretend that didn't happen. Look, it's a happy little mistake. It's a star. Okay, moving on. Okay. So first we need to figure out what a piecewise function is. So a piecewise function is defined by multiple sub-functions. So let me highlight that in blue. Multiple sub-functions. These are the sub-functions we're talking about. And then each sub-function has a restricted domain. And here are your restricted domains. It means that x can't be just anything. It's got to be a certain, certain range of values, something like that. Okay, the other thing about piecewise functions, it's kind of like you take a part of this graph and a part of this graph and a part of this graph and you put it together and it comes up looking like some ugly Frankenstein graph. So that's what's going to happen when you do these. Alright, so the first thing we're going to do is we are going to evaluate a piecewise function. Anytime you see that word evaluate, think about like calculate. You're going to have a numerical answer anytime it says evaluate. Alright. So here's some weirdness. We'll talk about this. Okay, we already talked about how it has multiple sub-functions, okay? And then it has restricted domains. So here is one sub-function and a restricted domain. This is another sub-function, restricted domain. And then this is your third sub-function and restricted domain. Okay, so we have three that we're looking at. And they're color-coded. So now when I get down to the bottom where it says f of -1, when it talks about -1, that's your x value. Anytime there's a number in the parentheses, it's going to be your x coordinate. So now we're going to try and figure out where does -1 fall in the restricted domains. So if -1 is less than or equal to -2, it's going to go in the red. If -1 is between -2 and 2, it's going to go in the green. And then last, if it's greater than or equal to 2, it's going to go in the blue. So think about -1. -1 is between -2 and 2, so it's going to go into the green one. Alright, so it falls into the green category. And then what you're going to do is you're going to take the sub-function and you're going to replace that x with the value. So where they have an x, we're going to replace it with -1 and then the -2. And then all you do is calculate. So -1 minus 2 is -3. So my answer is -3. I know that's a bit confusing. Just stick with me. Let's do another one. So the next one, we're told that x is 2. So we've got to figure out which restricted domain does 2 fall under. Is 2 less than or equal to -2? Is 2 between -2 and 2, but notice it's not equal to those? Or last, is 2 greater than or equal to 2? So it definitely falls in the last category. So we're going to use the blue. And so what we're going to do is we're going to take that sub-function, and instead of putting x, we're going to replace x with 2, the value it tells us. And then we're just going to calculate it. So you can do this in your calculator, or you can do it in your head. The answer is 0. Okay? And then the next one, we have f of 0. So once again, they're telling us that x is 0, and we got to figure out, does 0 fall into the red, the green, or the blue, looking at the restricted domains. So 0 is between -2 and 2, so it's going to go into that function. I'm going to replace x with 0, and so 0 minus 2 is -2. Okay. So we're going to do the same things for the last three. So f of -5. -5 is less than or equal to -2, so it's going to go in the red. And so if you look at the sub-function, it just says -4. There's nowhere to plug in an x value, so that's your y coordinate. That's your answer. Okay, so for f of 5, 5 is greater than 2, so it's going to go into the blue one. I'm going to replace that x with 5. And so that is negative 10 plus negative 6. And then the last one, f of negative 3. That falls into the red function. And I don't have to calculate anything because the sub function is negative 4. That's my answer. So sometimes it trips people up when you don't have like an actual x to plug it into, but those are meant to be, oh, and I erased this stuff. Those are meant to be easy, so just don't let that trip you up. Okay, so look at the challenge. These are the problems that you're going to see. It's going to be like multiple things. So when we plugged in f of negative 3, we got our answer was negative 4. We didn't do the next one, but we'll go ahead and do it. So I'm going to do this part. I'm going to do f of 1. So 1 falls into the middle category, this one. I'm going to replace that x with 1, and so my answer is negative 2. So negative 2, negative 1. Why can't I read? So notice what I'm doing. Anytime it says f of negative 3, I just wrote the answer down. And then it said plus 2 times the answer I got when I did f of negative 1. And then, kind of erased it a little bit. And then the last thing I'm going to do is minus 4 times the answer of what I get when I do f of 5. And we've already done that one. It's negative 6. Okay, so it's like you're going to evaluate a bunch of different stuff, and you're going to do whatever operation it says to do. So you can type that in your calculator all at one time, or you can do order of operations, whatever you want to do, but see what you get when you do that. So I got 18. Okay, so a little confusing, I know. I'm going to do another video where I do just some extra problems, so if you're having trouble, I'll try to help you out. Okay, so let's move on. So this time, we're going to evaluate. So we're going to calculate, we're going to get a numerical answer, but we're going to do it from a graph. So the last ones we did was from an actual piecewise function. This one's just reading a graph, but it works pretty much the same way. Oh, I just noticed that the graph is named g of x and all the functions say f. So normally when that happens, the graph shouldn't be named f of x. So let me just change that. Totally not like I stole that graph off the internet or anything. No. Okay, moving on. So here we go. Okay. So remember, the number inside the parentheses is x. So really what you're trying to figure out is if it gives you your x coordinate, what's the y coordinate? So the first problem, it's telling me f of negative 5. It's saying x is negative 5. I'm going to look on the graph and I'm going to try to find a point that's closed in, not an open circle, a closed in circle that has an x coordinate of negative 5. So if I look, oh, it's hard to do this with my finger, right there, that point would be negative 5, 1, 2, 3, 4, 5, 10. Okay? So when x is negative 5, my y coordinate is positive 10. That's what you're doing each and every time. Okay, let's try another one. The next one says if x is negative 3. So I'm going to look on the graph for a closed-in point that would have an x coordinate of negative 3. So if I use this point right here, that coordinate point would be negative 3, 0. So when x is negative 3, y is 10. Okay, let's do the next one. When x is 0, so I'm looking for a point on the graph that is closed in that has an x coordinate of 0. If I choose this one, it doesn't work because that is an open circle. It means that is not even a point right there. So I'm going to have to choose this point up here. That point is 0, 4. When x is 0, the y coordinate is 4. Alright, next one. When x is 1, what's y? I would have to choose this point. When x is 1, y is 3. Next one, f of 2. The only point that it works for is that one, 2, 0. So when x is 2, y is 0. And then the last one, f of 5. When x is 5, 3, 4, 5, I go all the way down here. That coordinate point is 5, negative 10. So when x is 5, the y coordinate is negative 10. So that's how you evaluate when you're looking at a graph. Okay, so notice the challenge one. The challenge is what your problems are mostly going to be like. So you're still evaluating it, but you're also doing some other stuff to it. So when we evaluated f of negative 3, we got 10. Plus 2 times when we evaluated f of 0, we got 4. Minus 4 times when we evaluated f of 2, we got 0. So you're just replacing whatever you got when you evaluated it with that f of whatever, and then you're just writing out all the rest of the stuff. So 18 again. Oh, that's weird. Okay. Cool, cool, cool. Alright, now let's look at how to graph a piecewise. Okay. So there are 2 different sub-functions with restricted domain. I'll make them Christmas colors. So we're going to make 2 different tables. And I'm just going to color code them so you know which ones I'm referring to. Okay. So some weird stuff you have to think about back to middle school. Alright, so my restricted domain for the red function is x is greater than negative 1. So I definitely want to include negative 1, even though it doesn't say equal to. I want to know what happens at negative 1. And then I want any value that's bigger than negative 1. So 0, 1, 2, 3. And then for this one, I don't have to evaluate anything because it tells me what the y coordinate is going to be. 5, 5, 5, 5. Okay, so here's what we're going to do. Because, if you'll notice right here, it says x is greater than negative 1, not equal to. Anytime we had a greater than symbol, we did it open. If it said equal to, we would close it in, just like you did back in middle school. But it's open because it's just a greater than sign. So I'm going to graph that point negative 1, 5, and I'm going to do an open circle. And then I'm going to graph the other points, and I'm going to connect them. And then those do continue on forever, so I'll just do a little arrow. Alright, so that's how we do the red one. Green one's a little bit more challenging. Not bad. So if you look at the restricted domain for the green one, it's x is less than or equal to anything, less than or equal to negative 1, sorry. So we're going to choose negative 1, and then anything less than negative 1. So hopefully that'll be enough. You can do more points if you need to. So I'm taking like this value and I'm replacing x with it. So 2 times negative 1 is negative 2. If I do the next one, 2 times negative 2 is negative 4. 2 times negative 3 is negative 6. 2 times negative 4 is negative 8. 2 times negative 5 is negative 10. Now I'm going to graph these points. So for this first point, because it could be equal to right there, we're going to have a closed in circle because anytime it has the extra little bar, that means a closed in circle. So negative 1, negative 2, closed in. And then I'm just going to graph all the other ones. And I'm doing this with my finger, so it looks horrible. Okay. And then that line keeps on going forever. So this is why I call it a Frankenstein graph. They don't overlap. It's just a piece of one graph, a piece of another put together. Looks weird, looks ugly, but that's how you do it. Alright, and then the last thing is we're going to do a word problem. So, sometimes these trip people up. Just make sure that you're reading this. So the cost of mailing a first-class letter with the U.S. Postal Service in 2006 was 0.39 cents for the first ounce, and then 0.24 for each additional ounce up to 13 ounces. So if you had something that cost, let's say it was 0.8 ounces, it says right here that you would have to pay 0.39 cents. So let's say you did 0.9 ounces. You would still have to pay 0.39 cents. If you did 1 whole ounce, you would still have to pay 0.39 cents. So if you looked at this on a graph, anything from 0 to 1, you would have spent 0.39 cents. Okay, and then I'm going to erase this just because I need room. And then each additional ounce up to 13 ounces is 24 cents. So let's say I have something that weighs 1.1 ounces. So I've already spent 0.39 cents for 1 ounce, and then anything additional after that is 0.24. Okay, so what I'm spending is now I'm spending 63 cents. But even if I spent 1.9 ounces, it would still be 63 cents. So it's going to look like this. Okay, and then if I spent, let's say I did 2.1 ounces. I spent 39 cents for up to 1 ounce, then 24 for the next one, and then because I went another 0.1 over, another 24 cents. So now I would spend 87 ounces. 87 cents, my bad. Sorry, I was trying to write and do stuff. So see how it kind of looks like a step function? That's what these are called, step functions. But they're also, you could also refer to them as piecewise functions. So, for instance, sometimes questions like these, they'll word them and it confuses people, but I hope it doesn't confuse you. Let's say you had a package that was 4.5 ounces. I want you to see if you can figure out how much money you would spend in postage if it was 4.5 ounces. So I'm going to pause it and let you try it. Okay, so let's see if you think about this the same way I do. So it's 4.5 ounces, so that first ounce is 24 cents. My bad, can't read again. 39 cents. 30, oh, where's my marker? And then the second ounce, you had to pay an additional 24. And then the third ounce, an additional 24. And then the fourth ounce, an additional 24. And because you went 0.5 over, you had to do an additional 0.24. Even though you only went half an ounce, you didn't spend half the 24 cents, you still had to pay the whole 24 cents. So that's why you have to add all of this together. So you end up paying $1.35 in postage. It's kind of like when you go to a parking deck, like if you go to Baptist Hospital or Forsyth Hospital, you pay like, I don't know, what is it, like $3 to the first hour. But if you only stay 10 minutes, you had to pay $3. If you stayed the whole hour, you paid $3. If you stayed 45 minutes, you paid $3. So that's the kind of word problems that you'll see, and just make sure you read it carefully. It's not a linear function, which is what people normally do because that's what you're used to. This is a piecewise, so it goes up in stages and steps. Okay, so I'm gonna have another video with just some extra problems if you need help, because sometimes that's a little confusing. Message me if you have questions. All right, bye.